Okay, let's look at this is for when the resistor and capacitance and inductance is combined lah. Okay, so this is for resistance and capacitance series circuit, RC circuit lah. Okay. So let's consider an AC source of RMS voltage connected in series to a resistor and capacitor. Okay, so the RMS current passing through the resistor and the capacitor should be equal since they are connected in series. Okay, so remember in series circuit the current should be equal lah. Okay, so this should have IRMS current juga. Okay, so the RMS voltage across the resistor and capacitor are given by this equation here. Astaga, ada typo lagi. Okay, so this is RMS. Nanti edit lah. Okay, so this is for resistance, this is for capacitance. Okay, so the phasor diagram of RC series circuit is shown here lah. Okay, where the phase angle is this one lah. Okay, so based on the phasor diagram, the RMS supply voltage is given by this equation here. Okay, so if you were to calculate for the VRMS, after simplification you will use this equation. Okay, so sorry, so rearrange the equation for impedance. We then get the impedance to be equal to this equation. So this is for calculation of impedance lah. Okay, and then if the question asks you to draw the phasor diagram in terms of R, X, C, and Z, you should draw it macam ni lah. Ini untuk RC circuit. Okay, so untuk RC circuit, the capacitive reactance always points down. Okay, nanti kamu akan tengok yang XL tu akan point upwards. Okay, so what you should know from this table is ini untuk cari VRMS, ini untuk cari impedance, and then you have to draw the phasor diagram. Okay, and then RCL series circuit. So untuk series circuit, again this will have RMS, this will have RMS also. Okay, so the RMS voltage is these two equations here. So the phasor diagram, kalau kamu tengok, for impedance dia akan sentiasa point upwards. Okay, so it will point upwards, and then to calculate the VRMS you will use this equation here. Okay, the only difference is this is XL, tadi itu dia XC. Okay, make sure kamu ingat mana satu maguna. Okay, and then rearrange the equation, we can then get the impedance. So this is the impedance lah. Okay, again ujung ni saja yang ubah. So this is inductive reactance, whereas this one is capacitive reactance. Okay, so from the phasor diagram, the supply voltage will lead the current by phi radians lah. Okay, so how do we calculate the radian is by using this equation here lah. Okay, so the phasor diagram in terms of R, XL, and and Z pula is shown here lah. Okay, so remember R is always on the x-axis, dia tidak akan berubah. Yang akan berubah is just the XL ataupun XC, and then Z mesti beginilah, angle ni jangan lain-lain. Okay, now is when all three of these are combined lah. Okay, again this will have the same current, so this is the equation lah untuk all three of this. So the phasor diagram is shown here lah. Okay, so untuk bila ada tiga-tiga ni, the capacitance will always point downwards, whereas the inductance will point upwards, and then untuk resistor sentiasa on the x-axis lah. Ini just to calculate lah which one dia akan point up ataupun point down. Okay, Okay, so the total voltage ataupun the RMS supply voltage can be calculated using this equation lah. Okay, so the difference now is it's not gonna be XL atau XC, it will be XL minus XC. Okay, so inductive reactance minus capacitive reactance. Okay, so from the phasor diagram, we can see that the supply voltage will lead the current by phi radians lah. Okay, again we calculate it using this equation here. Okay, so this is gonna be XL minus XC over R lah. And then in terms of R, XC, XL, and Z, this is the phasor diagram. Okay, so if XC is greater than XL, it will point downwards. If it's vice versa, it will point upwards lah. Okay. Right, now resonance in AC circuit, it is defined as the phenomenon that occurs when the frequency of the applied voltage is equal to the frequency of the RCL circuit. Okay, so this is the variation of XC, XL, RN, Z with frequency F lah. Okay, di sini. This is the point where they will have resonance lah. Okay, so the value of impedance is at a minimum when XL is equal to XC, which is this point here. So the value is given as the resistance, which is R here. Okay, so this phenomenon occurs at the frequency here, which is known as the resonant frequency. Okay, so at resonance, remember at resonance the impedance is at a minimum. Okay, hence the RMS current flows in the circuit will be at a maximum. So that is given by this equation here. Okay, so this figure is showing us the RMS current in an RCL series circuit, which varies with the frequency. So at frequencies above or below the resonant frequency, the RMS current is less than the RMS maximum current. Okay, so the resonant frequency of the circuit can be calculated by using this equation here lah. Okay, so the series resonance circuit is usually used for tuning a video receiver lah. So at resonance, the current and the voltage are in phase. Okay. Sorry. All right, that is the end of the theory part for our third subtopic.